European Commission, Copernicus unit. So this session is dedicated to Copernicus. The link between Copernicus and Inspire is actually mainly for the cross-cutting in situ component. I would like to present to you Hendrik Steen Andersen. He works for the European Environment Agency. Maybe you just okay. Okay. It's important that you know him, get to know him. He's the project manager for the cross-cutting in situ component of Copernicus. We are preparing Copernicus 2.0. What does it mean? Copernicus, do you know if it's a regulation or a directive? Oh. Regulation? What does it mean if it's a regulation? It means there's a budget linked to it. So we have the multi-annual financial framework in which there's a budget dedicated for 2014-20. It's okay? Maybe you can put the first presentation. So we're preparing Copernicus 2.0. It's the next regulation because, of course, there's a next MFF, Multi-Annual Financial Framework. What is very important for us is to see how Copernicus is being used, the data and the services. What is the purpose of the cross-cutting in situ component? In the regulation, you will see there are three components: space, services, and cross-cutting in situ. Maybe we have to rethink it. Maybe it's not defined well enough. Why am I saying this? The cross-cutting in situ component serves the Copernicus services. But you know that there are also in situ data being used by the space component within the services also, at their level. So this session is important for us to see what is going on, how are the Copernicus data being used, are there issues or not. So please feel free also to post questions or suggestions also for improvements, because you are here, you are our users, and we listen to you also, okay? Having said this, each of you, you have to know your representative in the user forum. Everybody familiar with user forum of Copernicus? It's the advisory body to the Copernicus committee, and it's your link to us then, up, okay? All right, so let's start. If it's okay, we start with the first presentation, Jan-Dirk Bullens from Wageningen University? Environmental research, yes, okay. I want to just to see together with you, is it okay that after each presentation we have questions? Is that okay, or do you prefer at the end? Okay, thank you. So after each presentation, 15 minutes for each of you. I'll be tough if you go over. Okay, so 15 minutes presentation. We have some time for some questions. One speaker did not show up, so at the end we will have some time for discussion. Okay, good luck.
Thank you, Katrina. So my name is Jan-Dirk Bullens, as told. I'm working at Wageningen University and research. More specific, that will be Wageningen Environmental Research. The talk I'm going to give you is about INSCOPE. So the people who were at the workshop 2 days ago, yesterday I mean, this will be a kind of rehearsal then, a summary of what we did then, but also some of the feedback we got at that workshop will be presented, and it would be interesting to have some more discussion on that as well. The project which was granted by the EA is to look how can Inspire contribute to the in situ component of Copernicus. There are some people involved in the project, so they are listed here on the front sheet. Myself, Torsten Reitz, Alejandro Guinea, responsible for CODA, and Hendrik, which is already introduced to you a minute ago. Basically, this is something I probably don't have to tell you, but it gives you an idea about what our focus will be in the project we carried out. So we didn't look into all the services which are provided by Copernicus. We looked specifically to the land monitoring service and the emergency management service. And the in situ data, which is ground-based data, as you know, are of course an essential integrated part of that. They are needed for validation, but they also can provide additional information at the other hand to these services. So basically the main objectives of this study were and are still, because it's still in progress, we are not finished yet. So is that we want to currently identify what is currently published by Inspire, and do these data sets meet the Copernicus needs for the in situ component. Also try to find in that study what were possible gaps, what are possible gaps, and what may limit their use if you want to use it for the Copernicus services. Assess these issues and try to see if you can estimate at least what will be improved still in the process of implementing Inspire, which is still coming up. And finally also propose if it's possible to have some measures to expand and improve the use of the Inspire capacities for Copernicus. So some general facts to start off with, as you should be quite obvious, it should be quite obvious that Inspire and Copernicus, they share the same key requirements. So they need the data and possibly, preferably, also in a seamless way. So across borders, across everything which is about interoperability. But Inspire is different in the sense that it is an infrastructure. It doesn't provide the data because the data providers themselves are responsible for that. And next to it, Copernicus is a data producer, at least that is for the remote sensing domain, satellite domain. Less for what is taken into the in situ component. But still, they do it differently, so they are also a crucial user for Inspire in that sense. And also we have to take into account that Inspire is a process which is not ended yet, so we have to still wait 2020, 2021 to be exact, to have everything ready if everyone does what it should be done within the context of Inspire. And a key issue is the alignment of all the data in the end to achieve interoperability. To see what we did in the project, I make a little graph which in the end will look quite complicated, but it will show you how we did the work. So focusing on only those two services, land monitoring and emergency management, we got from the Copernicus community what requirements are there. And for those services, we know that there are use cases using that services. Those use cases, they use data, not only from the services, but also data provided by the in situ component. So basically, what is done so far is that a lot of those data are, how do you say it? They are in a catalog, which is called CODA. And this catalog can be used to detect the data sets and also to download the data sets. There's a bit more on CODA in the next slides. But what we could also indicate is what would be useful from Inspire to add to that. So can Inspire add to Copernicus in this sense? To look at it in a little bit different way, that's how we assessed the different sides of this diagram. So CODA is looking at the data providers in first instance. So what are providers? So the national mapping agencies, what do they have as data sets? If they have data sets, are those published as services? Are they online? Are they well documented? If so, then they are registered in a database, serving as a catalog. And in that catalog also monitored is if those data servers will be available. So are they online and are they performing as they should? So that is a resource for Copernicus to see what data is already available and which is reliable to get data from. What we did for the Inspire side, which is less structured in the sense for Copernicus, but structured in the sense for the directive, is that you have a different entrance. So you start with the metadata metadata discovery, so to say. So from that point you can view and see and discover what data sets are relevant. From that metadata you can retrieve what data services are available, if this is provided in a good way. And then you have two shapes of that one, two kinds. The as is done for the most data sets so far, but also the harmonized one, which should be in the end for all data sets a mandatory obligation. Then you can go a step further to see what are the capabilities of those services. What are the typical objects which are inside those services, and can you use it? So this is the point where we're now in the project, and the next point will be matching this with the use cases, which there are, and see if there are gaps in between. And then see how can we overcome those gaps and bridge those gaps, in fact. A short couple of slides on CORDA. So it is a reference data access database, so to say a data catalog, which is a single entry point. And it covers national and regional geospatial data, which are digital available across Europe. They give you an index of URLs. So they do not contain the data itself, but they refer to the data as they are provided by the data providers. There's restricted access. You have to register because not all of the data are freely available, and licenses are bought through the Copernicus program. But they promise high accessibility and a high reliability, efficiency, and sustainability through decentralization. So it's a moderated process, in fact, but it should be simple of use. And they cover the teams of Inspire, which I mentioned over there. So the concept is, in short, go to the provider, see what they have and data sets, try to identify what resources are there, and no matter what kind of format they are presented, they are going to be collected in a data catalog. And then there is some functionality that the CORDA provides the links to the data sets. They are guaranteeing that they are working, and if not, it's mentioned already in the database. They have information on the latest editions, and you can easily filter by location. So next we're going to the other side of the diagram which I showed. So what we do for seeing what can Inspire offer for the in-situ component. That is that we did an analysis, the Inspire analysis, with the objective to perform an end-to-end usability assessment for the selected cases in the two services we are focusing on. And we have 4 elements which we would like to address. So discovery, compliance, coverage, and quality. The methodology we used, and this is a methodology which is covered by Torsten Reitz from WeTransfer, is that it is very strict in the sense that it should fit to the compliance rules of Inspire. So discover the data sets in the catalog, try to analyze that and retrieve the services which are behind, and see if you can download it and can assess what coverage there is from those data sets. For those, we didn't do it for all the data teams which are in the requirements, but we selected at least for the different annexes each one data set, one team. So for Annex 1, it would be protected sites. For Annex 2, it was land cover. And for Annex 3, it was buildings. So also differences in complexity and that kind of things. If you go into detail what the methodology is that get all the data from the catalog services, the Inspire GeoPortal, select the metadata entries for that specific Inspire team, and try to select it by a hierarchy level. So are those data sets declaring conformity? Filter then on, are there also download sets available? And if there are download sets, are they compliant to the network services? And trying to detect with the capabilities if there are structure information to be retrieved, and if you can count features which are inside of those data services. This is in short what is the result of this analysis, and the steps are indicated over there. So for 3 colors are the 3 different teams. If you look at protected sites, which is the gray one, then from the metadata catalog we found 1736 metadata sets, and they cover about 12, if I read it well, different services. From those services, 261, they are Inspire compliant. And from that 261, we have 22 services which also are compliant to the network services. And from the network service, they all are also giving good results at the get capabilities. But then there are only 2 who retrieve objects, feature types, and there is a 0 count of the objects within the in the data set itself. So this is a little bit disappointing. And we have some conclusions set at that. So this is a very strict analysis. So it means that if you say it like this, 0 fully compliant data services and network services are available. of this specific 3 analyzed themes. But we have also added to that the discovery process was a bit difficult in the sense that the compliance keywords are from the specifications, and when you have that in different languages, it's difficult to compare. So it should be easier if those were referred to as technical identifiers. And then the metadata resources are not really navigable. This is what we presented in the workshop also, and we had some questions about that. These are in short what we got as feedback from those questions. And one of the things which started up with that the requirements, which are very broad in the sense that we got them from the Copernicus services, should be more specific. So you are needing exactly good examples, best practices for that, and see what is the exact requirement for the different applications. And it means that it should also be fit for purpose, so the right quality for the intended use. Next, there was a lot of discussion about harmonization or interoperability, which are 2 words which are difficult to understand. But as we see it, you can have it at 3 levels. So you have a technical harmonization, which means that you apply to standards and that you use and follow the technical specifications which are set out. You can also have the harmonization on the semantic level, which means that you have to follow the data specifications in the sense that you have the definitions and the objects according to what is modeled in the data specification documents of Inspire. But next to that, you have also classifications which are used for the different attributes. And also there is a source of confusion that not all the member states use the same classifications. And last but not least is also that geometry should be aligned, not in the sense that objects fit together across borders, but also that you have use different coordinate systems and they should be fit together when you have one reference system used in the end for pan-European data collection. So about classifications, there was a discussion that there should be more harmonization, more collaboration and cooperation on what classification should be used across different countries, across different, well, European-wide, so to say. You can compare that more or less with what is done for the European location services. There you have some discussions on what classifications should be used for all of the countries. Then there is also a discussion about the readiness, or let's say the performance of the different data sets. So a lot of use is also made, especially in emergency management service for the OSM, because it's readily available, it's across borders, and it has a seamless kind of way of working. And the other thing is that, well, it's not authoritative, of course, and you should be aware that mapping authorities or mapping organizations don't release their data so easy, because always it should be ready in the sense that it is reliable, authoritative, and that kind of things. The other thing is that the metadata, which we already saw in our analysis, is not really fit to discover in a practical way what you want to know. So, and it usually relates to what's inside, so content-wise. So the recommendations were avoid textual inconsistencies and use common names preferable, so like controlled vocabulary. So you know what you're naming and will know what the definitions are of that. And also, well, if you have a search engine which you use specifically for this, it should be more custom. And one of the examples is already presented, I think it will be still presented also in this conference, the new Inspire viewer, where they have more custom-like searches. Then, improve quality and performance. So one of the suggestions was to use cloud technology for that, but be aware of what practical consequences that will have. One of the major things is that Copernicus is, of course, a major use of Inspire. And the question we asked the audience is Inspire improving the use of the in-situ component? And then the answer was, of course, yes. But also the recognition that we are not still there yet. And that completes my presentation so far.
Okay.
I have one question you can think about during the next presentations. So, because of what I presented as feedback, what could you think of that, and what could you add to that, like add-ons for Inspire, to make it more useful to use in the Copernicus context?
Excellent, thank you very much. We have time for some questions. Okay, anybody? I have a question for you. You say Copernicus is a data producer and a user of Inspire, but we know, for example, that there are also already examples of national mapping agencies starting to use Copernicus to validate their reference data. How do you see this? Are you going to look into this also? Because it's not a one-way direction.
Not.
It's yeah. Can you maybe say something about it?
Well, probably not too much, but because it's outside the focus of what we try to see what is the benefit of Inspire for Copernicus. But I think the user community is not only the Copernicus users, but also a different one. So that could be on a national level, it could be on different levels. That I think that requires a more in-depth study, and that's not included in this, but it's definitely something which is relevant. Yeah.
Yes. Okay. The example I was referring to is the Norwegian Road Authority and National Mapping Agency, and they're using Earth observation data to validate their Inspire road data. So this is what we're looking into. This is also important for Copernicus, that you have this mutual connection, actually. All right. Thank you very much. Okay. Then I would like to call the next speaker. It's an old colleague of mine. Yes, Henning Sten Hansen from Aalborg University. Okay.
Yeah, well, let me see.
Yes, because
here.
Mark Tondrio is not here, so it's immediately to you.
Good.
Okay.
I have to find my. Yeah, but I think I have checked that they are here. But yeah, I know. Yeah, thanks. Is it this one? No, it's this one. Yes, yeah, I have found it. Is it here? No, it's not there. I'm normally using a Mac computer, so where is it? This is oh, it's Acrobat. So I opened the wrong one. Oh, they are all in Acrobat. That's strange. Okay. Yeah. How do I do this? Can I do something? No. Okay. Nothing is happening over there.
Do you want to change it to PowerPoint? You
Yeah.
have to upload it once again if you have.
Okay.
You want
But
to use this? Or do I
yes,
have to
yes.
Prefer, but you have to look at there, so it's quite difficult. Does it work?
Oh, at least that's something.
Yeah, but you have only one screen, or I have to,
Okay,
or somebody else know how to synchronize those things again.
Okay, yeah. Then I'll go down here. Yeah, my name is Henning Sten Hansen, and I am professor at Aalborg University, Copenhagen, and leading this geoinformatics research group. I'll check the time. I know it's what? Microphone. Oh yeah. Sorry, everything is okay. A little snake here. It's yeah. As I said, that I am professor in geoinformatics at Aalborg University, Copenhagen, and I am leading a group of researchers there. And actually, I am mentioned as the first author here, but actually I have not been involved in this project at all. But Jamal Yokar Sanjani, who has been leading this, was not able to come here. So, but anyway, I hope that I can go through this without any problems. It's about using Sentinel 2 data for mapping European landscapes and taking outside in a case study in Denmark. I think I can just have everything remote here.
Excuse me, do you want this mic?
Yeah, that's better. And then this snake. Can you hear me now? Yes. And then the next technical problem. It's okay. Control L. I should be a Windows user instead, I can see. Instead of all this Mac.
And then they say something about launching a satellite.
Yeah. Okay. Now it's not working, so. Yeah, so I can jump up and down here. There's has been a general lack of global and regional fine-scale land cover products. We had Landsat, but it has not been so detailed, and it has not been a continuous. It was broken down by George Bush, and I do not know what will happen with the new famous president in US. But what we do here, we have the Sentinel 2 series. We believe that although Katarina talked about they have to find new funding for the next process, that we are in a more sustainable production of satellite data. And what is mainly we are interested here at our university is the land cover information. And I think when I'm asking you everybody, you will be focusing on these Sentinel-2 data. Of course, there are also radar. The main objectives of the study has been to explore the potential use of Sentinel data for land cover land use mapping. And we have done this in Europe, more precisely in Denmark at the moment. And what we have tried to do is to compare several pixel-based algorithms for the classification of discrete land use classes. And there are many possibilities, and I will come back to this later on. I have to... Yeah. We have selected a little area of northern Jutland, Sentinel-2 data for 10 times 10 meter resolution. They can easily be downloaded from ESA, easily, in some degree at least. But I had to be friendly to Katarina here, so we have found cloud-free products, and we have used a lot of bands with different kinds of resolutions, but we have mainly focused on the 10 meter. Perhaps when I'm sitting here in the at the Inspire conference, it's not so usual to use the IPCC land cover classes. Quite often we are mainly using Coherence. It's more detailed, but for the very global analysis of or classification of land cover, it's useful not to have too detailed classes. So we have only settlement, forest, cropland, grassland, wetland, and other land, and then water. Then we have, I say we, I haven't been involved, but sorry. We have used 3 different kinds of algorithms. What is the most often used method is the maximum likelihood classification, which is also quite straightforward to use, etc. And it is included in so many software products. But for this purpose, we have some experience that maximum likelihood not always get the right or the right classification of the satellite image comparing with in situ data. So we have also been dealing with some newer algorithms, the random forest, and support vector machines. I will not go into detail because I heard that Katarina will be tough to ask me stopping. We have collected quite detailed ground truth data from Cord 10. It means map 10. It's quite our most detailed topographic database. We have for the Danish Agrofish Agency, this is not the name any longer. Typically Danish agencies, they are changing names every year, at least. So I do not know the name at the moment. But the data are still the same, and from that we have very, very detailed information about each parcel in the land for grassland and for cropland. It is mainly used for subsidies, agricultural subsidies for the EU. And then we also have the Danish Natural Environmental Portal, so we have really very, very detailed information. They are reliable, accurate, and they are also timely because it's updated very frequently. So, and that's of course also very important when you want to compare it with satellite images. We have selected a list of sample points using equalized stratified sample, an equal number of random spatial distributed points selected from each class. Then the selected cells are visually verified using very detailed high-resolution aerial photos, 12.5 centimeters, so it's nearly you can see my head if I was standing in the field there. So, and then these cells are then prepared for input as training and testing pixels. We developed two data sets of training and testing pixels split with 75% training and 25% testing pixels. And the two was 225 training and 75, and the more detailed one 750 versus 250 testing pixels. And yeah, they were done some filtering to the move data overlapping, etc. And but it was oh, did I took two? Yeah, but I'm not able to go back. Sorry, you didn't. You'll not have the possibility to see it. It's strange that they have uploaded a PDF file. Okay, but the results is that you can see here we have done this many times, and we have found out that actually the maximum likelihood is the one performing least perfect, I will say, with about an overall accuracy about 50% or 58 and 58 for the overall accuracy, and the kappa 51. And the supporting vector machines is clearly the best one, actually quite much better. And then, of course, it's also perhaps it's not so surprising that you will have better fit when you have more image band 9 compared with only 4. But still, I think it's surprising that the support vector machines actually with only 4 bands perform better than maximum likelihood with 9, at least in this case study. How long time do I have left? 5 minutes. Okay. Here we have the baseline. It's based on 9 bands maximum likelihood. Actually, we should have compared it with the hidden slide, which I couldn't show you. It was about the classification based on in situ. But anyway. Just keep it, think how it looks like, and then the best one. And if you really compare it with the hidden slide, they are really very good fit between the two. And the third one, this is very bad, based on maximum likelihood and only 4 bands. But it's also that it only have a fit about 50%, so that's not very good. we have. It's clear that the Sentinel data gives us some good opportunities. We can boost the quality and temporality of our observations. They are coming very frequently, and it is a sustainable platform. And we also have believe that from the global perspective, in Earth observation, for example, the areas in Africa and Middle East and Asia spreading due to climate change, we believe that this can be done. I've just got a project dealing with the creation of refugees in Africa due to climate change, and so we are making some modeling of this. And for that, of course, we also need to have some knowledge about how the land cover is changing in Africa. I think it's very important that we could have better facilities for getting the data. As I said, they could easily be downloaded, but it is not so easy as it can be used by just everyone. These are researchers, so they can find out. But I think that one of the goals, which also Katarina and her team is dreaming about, is that we can use Sentinel data and other Copernicus data for just a lot of tasks be carrying out in private businesses and local government. But until now, I think we have to see that this will happen. And this is clearly that there must be some very finished or just off-the-shelf software to do the classification, to do the identification of changes, etc., and also in a very user-friendly way. We have demonstrated here that machine learning algorithms are much better, or clearly better, at least from this case study, than the traditional maximum likelihood method. Of course, it can still be improved. Here we have used a Python, a special Python library for doing this analysis. You can also actually do this in ordinary ArcGIS today with not so many degrees of freedom, but anyway, it's much more user-friendly. So in that way, it can also be used of perhaps semi-experts in remote sensing. I only need half, so that's perfect. What we would like, for example, it could be that the Coherence could be in that way also be enhanced from 100 meter to 10 meter resolution, because in that way it will also support the use of the data. For example, as Katarina mentioned in her introduction, that it could be very nice to use this for detecting changes for roads, etc. And with 100 meter resolution, then perhaps it's not so easy to do it like if we are doing it at a low resolution. Yeah, thank you for your attention.
All right, thank you very much.
And sorry for the technical problems, but
once again, a very interesting presentation. Questions from the public, please? Yes. We will, or maybe you can come here and ask the question. Yeah.
Oh, okay.
Yeah, don't worry. Here. But you have to.
Okay, thank you. I work for a local regional SDI.
Yeah.
My question is that you mentioned that you can reach 50-55% of accuracy.
Yeah.
People on the local side are used to photo interpretation. That means very accurate data, and they are working with it. So my question is, do we have to wait for better accuracy of the satellites and the processes, or do we have to change the users because they have to learn how to deal with less accurate but more frequent data?
Yeah, thank you for the question. First of all, I think that it is not 50% accuracy. It's actually if you're using the lowest quality algorithm, if you're using the best one, the machine learning algorithm, then we actually reach 75%. And I think you should also look at Copernicus data and all other multi-channel data that you have actually an additional eye. You can see infrared, you can see thermal, you can see much more. With my eyes and your eyes, you can only see red, green, and blue. But with the satellite channels, multi-channel pictures or images, then you can see much more. You can see if the forest is sick, for example. Yeah.
Yeah. Yes. Is it working? Yeah. If I may, yeah. One question. It is not completely clear to me if you base your analysis on one image or several images. I mean,
several images.
Yeah. So I mean, an add-on question then would be: could you imagine that you would improve the accuracy by expanding the feature space by including other types of satellite data, for example?
Yeah, that's always a trade-off between, because if you have very few classes, as you can see here, then you will have a lot of impurities within the otherwise actually homogeneous areas. So this is always. But on the other hand, they can also, if you have very many classes, there could be too little signal within each class to determine the class exactly. So this is kind of a balance that you always have to address when you are designing your analysis.
Maybe just a comment on this, because we are doing quite the same analysis just in another area, and we define actually more features based, for example, of the evolution of vegetation indices over several months, and we just perform maximum likelihood by now, but we have we achieved 10% more accuracies with additional features. So
yeah,
but it depends on what classes you have.
Yeah, it is. And if we looked into another area in my own country, I looked into Italy or France, or we can also see that we could have a better accuracy, for example, also for maximum likelihood. But anyway, this is the first time we have done this using the machine learning algorithm, and just found out that at least it seems to be clearly more accurate than the traditional maximum likelihood. I'll not say that it's the best one, because you can also have different kind of other machine learning algorithms. It's really a growing area. So next year perhaps it's something totally different.
Yeah, I wasn't I wasn't telling that we have 10 more % than you have, but we tried in our region for maximum likelihood without these features and with those features.
Yeah.
And for our region, we became 10% more accurate.
Yeah,
so
but
that's why. Sure, it will be different, but
yeah.
I think it's worth a try.
Yeah. Thank you for your comment.
I have a question about the hidden slides.
I can find it.
One clarification, because you were mentioning the fact that you're looking for possibilities for the Landsat data to be integrated. Also, so this is actually referring to this DIAS and that the European Commission is financing. It's the Data and Information Access Service platforms. They hopefully will be operational next year, where you are going now to the what you call ESA website, but you should actually say Copernicus.eu website. Sorry, it was just well, no, sorry. Where we provide the Copernicus data and service information is at the Copernicus website. You have to go, of course, now to ESA to download images. It's a bit of a cumbersome process sometimes. So please feel free to also tell me what are the problems, because this is how we can improve. But we have these platforms that will be developed and operational next year, and that would be exactly to provide the data and information in a more smarter way, efficient way, as web mapping services, as web processing service, hosting facilities. This is exactly what we're working on, okay?
That of course will change the agenda in some way with because if you have some web processing services available, then you can actually use the big server there, so you can limit the number of data you are getting. Yeah. So, but I thought this DS should have been finished for some period. I was promised.
Can we go to the next speaker? We're running out of time. Thank you very much. Okay, let's please go. I would like to call Mr. Kelvin McCoy from the Mellon Technology. Thank you very much. You have your presentation.
Okay, thanks for the introduction, Katharina. My name's Calvin McCoy, and I'm from a company called Mellon Technology, and we're based in Ireland. Over the last while, we've been looking into mapping and identifying burn scars from wildfires on the Irish landscape. So when there's a wildfire, obviously, the scar that's left afterwards. As the title of the presentation suggests, I'm going to be looking at examining the applicability of Sentinel-1 radar data for identifying wildfires and burn scars on the landscape. Okay. So I've just noted a couple of points about wildfires in Ireland. The first one is that out-of-control wildfires cause significant damage every year to the environment and the property, including forestry and agricultural holdings. So I think everyone's probably aware of the damage throughout Europe caused by wildfires, especially recently in Portugal and the Mediterranean. Well, in Ireland, even though we have a much colder climate and so on, we have a lot of the same problems, a lot of the same damage. The second point I've noted is that most wildfires in Ireland are usually the result of unforeseen or careless actions. So rather than being caused mainly by the weather, by heat and so on and so forth, they're generally the results of either accidents or careless actions on the part of farmers and other people. People can hiking, camping and so on. Finally, I've noted that in this year in 2017 has so far witnessed a particularly large number of wildfires across the country. So it's been a very, this whole issue received a lot of media attention, a lot of political attention, which is one of the reasons why we got involved trying to map wildfires or burn scars across the country, and see how we could do it. So I've just put up two examples here of, I suppose, two of the most spectacular, if you want to call them, wildfires that have happened in the last few months. The first one is in a place called Guggenbarra in County Cork, which hopefully you can see is down in the southwest of the country. Here's a picture of the area. It's very scenic. It's a tourist area, basically, lots of hiking. This is a little church in the middle of a lake in the area. This is an image of the area on fire, which was from the 25th of April this year. And then we have an image of the aftermath, so you can see the kind of damage that's been done, the amount of vegetation that's been burned, and even on the left, you can see it's still burning in this image. The second example is from Cluj Valley in County Galway. You can see on the map here, it's in the west of Ireland, not too far from Galway city. It's actually this area is the biggest wind farm in Ireland, and it's also one of the largest areas of state-owned forestry in the country as well. Here's another picture of it on fire in May, 9th of May, this one, and just an image of some of the damage done afterwards. Again, you can see the amount of vegetation burnt and all the damage that's been done in the charred landscape. Okay, so some key challenges that have come up for us when we're trying to map and identify these burn scars. The first one is to identify and actually delineate them across Ireland. So looking at what kind of satellite imagery can we use, what methods can we apply to try and identify and map these things. And secondly, one of the key challenges is to disseminate this information across various organisations and institutions so that it can be used to enhance the prevention of and response to wildfire events. So obviously we want to map this data, but then we want to be able to give it on to other organisations and institutions in Ireland and elsewhere, whoever needs it, to try and help them. Okay, so identifying wildfire burn scars. In general, we've used open source optical satellite data, so Sentinel 2, Landsat 8. This is an example of the fire, the second one in Cluj Valley in County Galway. This is a Sentinel 2 image using shortwave infrared. And you can see the scar, hopefully, there's the big red area basically in the image. And hopefully you might be able to appreciate the kind of size of the scar as well. This is quite zoomed out. And I suppose this is one of the biggest fires in years and years in Ireland. It caused a lot of damage. Here it is up closer. Some of the darker green areas are forestry, and you can see that the actual fire spread into and damaged a lot of the kind of forested areas. One problem, well, I suppose the biggest problem we have in Ireland, which other countries in Europe probably don't have as much, is cloud cover. So using optical imagery, it's great, it looks great when you can get good images like this one. But in general, this is the kind of thing that we have to deal with. These are just 5 images taken from the month after the Gougane fire from Sentinel 2. So I'll just run through them. The first one, the second one, and so on. So that's basically a common occurrence across Ireland. You think, can we find a good image? And you might get one every 4 or 5 months, and that's it. So basically, we've had to look into using other kind of methods, other satellite imagery to see can we identify some of these scars. So we started looking at radar, and in particular Sentinel-1 synthetic aperture radar. So some of the benefits of this SAR data is that it can see through clouds and smoke, which I suppose is the most important thing for the concerns that we have. Secondly, it acquires data during both day and night. It's sensitive to moisture content, which can help in distinguishing post-fire burn scars. And Sentinel-1 data in particular, which is a C-band radar, it has a high repeat cycle over Ireland. Every 3-4 days, we get a new image, so there's a lot there to work with. So just looking at using SAR data and burn scar identification, it's actually quite an underdeveloped area of research. Not too many people have been working on it, and not too many people have gotten, as far as I know anyway, have gotten wonderful results from it. So we've been examining the following measurements that I have listed up here to see can we use this data to identify these burn scars. So we've been looking at intensity, coherence and polarimetric variables such as entropy alpha and anisotropy. SAR data, if anyone uses it, probably knows it's much more complex data than working with the optical data. There's lots of measurements you can get from it and lots of uncertainties and difficulties. Just looking at one study area here in particular, this is the first fire that I showed you from Gougane. So we took 5 single-look complex products downloaded from the Copernicus Open Access Hub and processed them using ESA Snap Toolbox. So we took two pre-fire images, one from the 12th and one from the 18th of April. One image when the fire was occurring, that was on the 24th of April, and then 2 post-fire images from the 4th of April and the 5th of May. So looking at the first kind of measurement, which is intensity, there's just a quote here, which gives a basic definition. It's a conventional measure of the strength of radar signals reflected by a distributed scatterer, usually expressed in decibels. So when the radar signal hits or comes into contact with objects on the ground, it's scattered in various directions, and the strength of that signal coming back is measured. Just underneath the diagram, underneath is the processing chain that we've been using to come up with these intensity measurements. So an example of the results for Gougane, these are the 5 images from the 5 different dates, starting with the earliest one in the top left, the pre-fire, and ending with one of the post-fire images from the 6th of May. The blue box there is the area of interest, and just the dark black bit in the middle is the lake at Guggenbarra. And the fire kind of, I suppose, it affected all the area north of the lake and northwest of the lake. So in these 5 intensity images, as you go through them, pre-fire to post-fire, just visually, you can't make out anything different really in the images. So initially it kind of seems, right, what can we do with this radar data? Is it actually any use? So one simple thing you can do is just begin to look at the difference in intensity values between different images. And this actually brings up some really interesting data. This is just an example of using the Snap toolbox to create these different images. So this is the result here. The first image on the top left is just the difference in intensity values between 2 pre-fire images. So you can't, obviously the fire hasn't occurred, you can't see anything sticking out in the image. The second image in the middle, in the top middle, is a difference between pre-fire and during fire images. So you can see now this black area in the middle of the image is actually the burn scar being picked up by the radar intensity data. The third image on the top right is the difference between a pre-fire image and a post-fire image. So again, you can see the same scar, only it's a bit more developed. There's been more burning as well. So I'll just move on. So this is an RGB composite of 3 of the different images put together. And again, you can hopefully see the scar quite clearly here. In black in the middle, there's some blue as well, which is produced from some later burning, which is coming through. And even at the very bottom of the image, you can actually see a small black and blue area, which is the result of another smaller fire that happened around the same time. These are just some stats, I'll just skip through these for now. Second measurement we can look at is coherence. So it refers basically to the amplitude of the complex correlation coefficient between 2 SAR images. It's a complex enough measurement. This is the processing chain we use at the bottom as well. And I'm just going to show you the visual results. The top 2 images on the left and right show 2 images, 2 RGB composites composed of 3 coherence images. And in both of them, you can see the burn scar sticking out in pink, obviously pink in the one in the top left and blue in the one in the top right. And the bottom are just composites of coherence and intensity images. And again, you can see the scar sticking out in these as well. How long have we got left? Sorry.
4 minutes.
Okay, right. The last kind of measurement we looked at was polarimetry. Again, a complex enough kind of measurement. There's a quote here. It says, many radars are designed to transmit microwave radiation that's either horizontally polarized or vertically polarized. A transmitted wave of either polarization can generate a backscattered wave with a variety of polarizations. And the analysis of these transmit and receive polarization combinations that constitutes the science of radar polarimetry. So we can carry out a polarimetric decomposition on the images, and we can look at measurements such as entropy, which is essentially a measurement of the scattering degree of randomness. Again, I'm just going to show visual results of this really, just to give you an idea of how it's being picked up. Yeah, here we are. Okay, so you can see the scar in blue this time. It's not as clear as with the intensity and coherence images, but it is there and it has been picked up. Just have a boundary around it there. And if we actually zoom out on that image and look over to the west, you can actually see another burn scar in blue being picked out. And there it is up closer, just with a boundary drawn around it as well. Just coming to the end now, these are just some quick images from the Cluj Valley fire in County Galway. This is the Sentinel 2 image, the optical image, and I'm just going to show you some of the radar images that we've managed to construct. This one is a coherence image. Yeah, hopefully you can see the burn scar in yellow. Another RGB composite of coherence images. You can see it again in blue. And finally, coherence and intensity difference composite, and you can see the burn scar in orange here. Actually, in this one, you can actually see the area of forestry in dark green. You can actually pick out some of the burnt areas of forestry better than in the previous images, for example. Finally, okay, where to next? So what we want to do is basically examine ways of incorporating optical and SAR data on burn scars into a national data set with Inspire compliant metadata. So we want to create a national data set, make it Inspire compliant, and then try and disseminate that information to other organizations so they can use it and, I suppose, help in prevention or help with post-fire recovery and so on and so forth. Okay, so, thanks.
Thank you very much for a very interesting presentation. Are there any questions in the room? I have a question on the use of in situ data. Can you maybe tell about, have you been using, which in situ data have you been using?
Really, we've just been using the imagery, Sentinel-1.
Only imagery?
And
Right.
yeah, we've had some people going out, obviously testing to see, doing some ground truthing to see, but we've only been using Sentinel-2, Sentinel-1, the optical and radar imagery. Yeah.
Okay, because of course we're at the Inspire conference. Okay, I understood that. You say, okay, these results, we will try to find a way to make them Inspire compliant, but I was more thinking of, did you use or maybe combine with Inspire data teams or not?
No, we haven't actually, no.
Are you thinking about?
Yeah, it would be a good idea, absolutely. This is just kind of in a preliminary stage. We were just trying to see, can we get any results out of it? And then if the answer was yes, then obviously we'll go and try and...
Yeah, excellent. All right, okay. Questions from the public? Okay. Yeah, sorry, yeah.
Do you think that method could be, I don't know how much is human intervention, how much you can, or to which level of automation you could push it in order to become something operational that could serve emergency managers?
Yeah, the actual process of, I suppose, coming up with those images is straightforward enough. There's a lot of data involved, like a massive amount of data and a lot of processing, but you can create automated processing chains to get to that point. I guess after that, the next thing is trying to create thresholds and classifications to actually extract the data, which is more difficult. I mean, I've just been showing images basically, but to actually kind of extract it and use it as a vector, create a vector data set from it is more difficult, much more difficult than using just optical data. There's a lot of speckle involved and things like that. But
did you maybe do? Okay, we are in Copernicus session, so.
Sorry, maybe you can introduce yourself. Sorry.
Yeah,
apologies.
sorry.
Maybe next time, if you ask a question, please introduce yourself. Okay. So
My name is Vanya. I'm from the Joint Research Center in the group who's implementing the emergency management service of Copernicus. So I was wondering, did you look into what you could get from EFIS as a comparison?
Yeah, we actually did. We did as much as we could with Sentinel-2 and Landsat 8 optical data, and we looked at the whole country, burn scars across the whole country, and we compared them to the EFIS data, obviously the MODIS and the VIRS, and I think we found just between, say, March and May, using the optical data, we found about 300 and 350 burn scars across the country. I think the data from MODIS, VIRS only picked up maybe a third of that. So 65-70% more burn scars we found. Yeah, so.
And how easy it was to understand the data coming from EFIS?
It's fairly easy. Yes, I suppose.
For accessing? I mean.
Yeah, accessing is easy. I found it fine anyway, yeah.
But also, I mean, literally getting the data, not just seeing it in the web interface, but also.
Yeah, we downloaded it as vector files. Yeah, and put it into our GIS, so that was fine.
Okay. So you don't see a need in.
I suppose just a need to improve the.
Inspire question.
I'm trying to remember how I downloaded it. Actually, I don't remember there being a problem. So. Okay.
This is good. Thank you.
Any more questions? Okay, thank you very much. Let's go then to the last presentation, which is Angel Lopez Alos from ECMWF. Hello. ECMWF is the interested entity for the Copernicus Climate Change Service and Atmosphere Monitoring Service.
Sorry, it's not easy to manage this. Do you know how to? Yeah, but there is no mouse. I think that. Okay, thank you. No. Okay. Sorry, I cannot see from here. Okay, so thank you, Katerina, for the introduction. My name is Angel Lopez, and I'm part of the technical team which is implementing the Climate Change Service, which I will try to explain. So the idea of the presentation is to explain what is the aim of the service, what are the challenges that we are facing, what are the different components that we are putting in place, and how the Agile methodology that we are implementing is helping us in order to be flexible and to prioritize the developments that we need to put in place in order to go ahead with the development of the service. Well, I know you are all familiar with the Copernicus program, and as Katerina was saying, the ECMWF has been entrusted by the Commission to deploy and run this Copernicus Climate Change Service. At the core of this service is the so-called Climate Data Store and the Toolbox. And the idea of this Climate Data Store is to provide access to climate information, to past, present, and future, and different kinds of related climate information. And the idea is to make all or most of this information INSPIRE compliant. So there is a huge amount of different data that we are going to deliver through the service, which is one of the challenges that we are facing. We are aiming to provide from observations to essential climate variables, climate reanalysis, model outputs, and so on, everything through the same user interface. So this diagram allows us to explain the complexity of the system. So the idea is from all this complexity of different data sources, the different data sets related with the climate change, is to put in place different components on top of that in order to make all this data accessible to the final users in the most simple way, and even to perform actions and to deploy applications and to make use of this data with more complex tools and functionalities. So the first component that we are putting in place is what we call the adapter, which allows us to interfere with the different data sources. Then we have this broker, which allows us to manage all the different connections to the different data providers. On top of that, to allow us for the interoperability of these different data sources, we are aiming to create this common data model, which will allow us to combine different data. On top of that, we will offer the possibility to apply different tools in order to manage the data and work with the data. We will offer also the possibility to create workflows, so different tools and combining different tools and different data sources, and at the end, the possibility to create final applications for different kind of users. So one of the challenges is this complexity of users that we are trying to face. So our aim is to provide access to users that they are interested on raw data, but also to other kind of users that are more interested on more elaborated data. The interface should be unique for all of them, so the philosophy behind is the same. So behind this, which is another complexity, is the different formats of the different data sets that we are going to provide. Some of these data sets are very huge. We are talking about petabytes of data. And the formats and how this data set can be accessed is quite diverse. So we need to put in place all the different components in order to be able to simplify all this complexity. Because at the end, what we are aiming to is to offer the user the possibility to discover the data in the most simple way. For this, we have a catalog. For the user to analyze all the information that we offer about the different data sets that we provide. We also put in place a data request functionality, so for the user to subset information from the different data set and to retrieve this data. And with all this functionality, which we call a toolbox, is to provide the functionality for the user to create application or to access this application and create these workflows. For this, we need to put in place many different components at different levels. So we need to create interfaces, different ways of interfere with the service. We need to create some components in the back end, and we need to put in place those components in order to be able to access different data providers. So on the top, on the interfaces, we have the web interface, where the user will come and to discover and to retrieve the data. We are also aiming to create an API to access this data. We will offer standard services to the user. We will offer the catalog service. And to offer all this in the back end, we need to put in place other core components, which are all this, the way of providing all these compliant data services. We need to put in place all the catalog for the data. We need to put in place, which is one of the most important components, is the quality of service. So we need to guarantee that the data that we provide has a quality control. And we also create this toolbox. As a step in this development process, there are some of these components needs to be inspire compliance. So we have the catalog, which is based on GeoNetwork. The idea is to create all these metadata records for the different data sets that we are aiming to provide being compliant. We also need to provide the services to this data being also compliant to the Inspire. For this, we are putting in place the SmartMet server, which is bringing into the platform by FMI. And also, the data supplier may directly offer the access to this data. So each of these components, and this is work in progress, and is where the Agile methodology is helping us to go ahead. We have the catalog. Now we have in place the GeoNetwork catalog. We are start putting information in there. And now the discussion that we need to agree is that the level of granularity is the issue that we need to face now, how to split the records in this catalog. We also have these view services that we are going to offer. For this, as I was saying, we are using this Smart Met server, so there are also some discussions and things that we need to solve is how many parameters are we going to offer as under these services, because the complexity of some of the data set that we are managing is so huge that we need to go step by step, so we cannot cover the whole complexity of the data set in order to try to make it all of it compliant. So we need to check. Also, as we need to ingest the data into this Smart Met server in order to create these services, we need to solve some issues with all the different data formats and of some of the data set that we are aiming to deliver. So it's another work in progress. So each time we receive a data set, we need to test it against this ingestion, and we need to check, and we need to fix something into the component. And for the download services, it's another discussion. It's still work in progress, but there are some ideas being by FMI about how we can progress with this. But again, it depends on the data set that each data set is a different casuistic, so we need to analyze each data set differently and to consider how to proceed with each of them. Coming back to the granularity, because we have discovered that this is a very important issue, and we are having discussions about this topic, is based on the different components that we have in the infrastructure, what is the level of granularity for each record that we are planning to put into the catalog. As we have, as I was saying, huge data set, how we can split this in order to make it more accessible and more so user can understand how to discover the data. The balance is we have a component to allow the user to make some request on top of this data set. And we also have the record in the catalog. The more complex is the request functionality. The simple is the level of records in the catalog, and in the other way around. So we need to find the right balance. To develop all these components, there are two teams working in parallel. One is working in the core infrastructure of the climate data store. It's a consortium led by Telespazio. FMI is also part of it. And there is another consortium which is developing the toolbox, which is led by a company called Be Open. And both groups, they are following this Agile methodology. So the idea is that each team has a list of tasks to be performed, and we are able to switch actions between the two teams in order to combine and to integrate both developments into the final solution. So at the beginning, they were working independently in different components. Now that the components are already in place, there is a continuous discussion among them, and there is an exchange of information and requirements in order for them to progress into this integration. In parallel, we have in place already most of the components that we need to start progressing with the integration of the different data sets. So now the work that we are doing is we are taking all these data sets that we have. we are testing these components, and then we are trying to put in place all the different elements that we want for each of the data set. So we first discuss about how to put these records in the catalog, then how to deliver this data, how to provide access to the user to this data, and then how to create these services on top of that. So at the end is this agile methodology, which allow a continuous interaction and continuous testing, and allow to prioritize the task when you are developing, and in order to be flexible to manage and to adapt all the development of the components in order to progress accordingly with all the requirements that we receive. And that's all.
Thank you very much. Any questions? Yes?
Thanks a lot, Angela. Just one simple question regarding the future structure of published data, either for view and download service. Are you planning to somehow categorize them by the countries, or it will be one data set for the whole Europe, or you have some idea what will be the sort of internal composition and structure of those data which you are planning to publish? And just could you give us indication how many of data sets it will be, just if you can already now from your experience to share it with us, the size of the amount which we can expect from this initiative. Thanks a lot.
Well, about the...
Sorry, I forgot to mention I'm from environmental agency in the environmental domain from Slovakia. Thanks.
About the dataset that we are planning to bring into or to provide through the infrastructure, we have from our reanalysis as in the weather center, which is, we are talking about currently, I think it's around 5 petabytes of information that we have. So the complexity is quite high. So we need to decide how to split this. We cannot provide access to everything, and impossible to do it through standard services. We need to decide first how to split this into the catalog in order to allow the user to access this data, this raw data, and then what we can bring into this SmartMed infrastructure in order to deliver standard services. So our idea is to bring sample data at the beginning, to offer this to the users, and then depending on requirements, consider how to extend, or if we need to bring more parameters into this sample to make it more complex and so on. The diversity is so huge that we have from these petabytes, and we have also data sets which are megabytes, very few megabytes. So each different data set, the integration into the infrastructure of each different data set is a kind of a small project inside, because the problems that we face are completely different.
Thank you. Bart Delethauer from the OGC. I had a similar question on the size of the data, so I'll ask you my backup question. I was expecting the word data cube in your presentation. I think you just explained it, but you haven't used the term. Is that something that you're looking into?
Data cube, you mean?
Yeah.
Yeah, it's part of this toolbox that we are using.
Yeah, but you haven't used the term, so I just...
Yeah.
Okay.
Yeah.
What's my backup question?
No more questions? Yes.
So maybe the last one. Is there some indication when the first samples could be accessible? Just estimation.
Well.
Oh, you had some diagram, roadmap, but I don't remember if there was something in that direction.
I cannot give you a specific date. Okay. What I can tell you is that most of the components are already there, and we are in the phase to populate the information inside in order to open the system with real content and real functionalities for the user. So hopefully it will be soon.
All right. Thank you very much. Bear with me one more minute, please. I would like to thank the speakers. And for each presentation, I will point out one or two elements which I thought to be remembered. So I'd like to thank Jan-Dirk Bulens from Wageningen Research on the presentation on the study of how Copernicus is a user of Inspire. And what I remember, or what is important, is the timely implementation of Inspire, which was also said already in the plenary session today. I would like to thank Henning Sten-Hansen from Aalborg University. His presentation was on the use of Sentinel-2 data to map European landscapes. And I remember what was remarkable for me was the trade-off on accuracy and frequency of the images. I would like to thank Calvin McCoy from Mellon Technology. What was interesting, what we already know, of course, is if you use optical images like Sentinel-2 and Landsat 8, you have the possibility to have a lot of clouds in Ireland, in UK, Nordic countries. So the attempt or the project to use Sentinel-1 radar data to identify fires and burn scars is a very interesting one. I have a to-do element is to check the possible use of Inspire data teams. Yeah? Okay. And finally, would like to thank Angel Lopez-Alos for his presentation on the inspired components to make the elements of the climate change service Inspire compliant, or try to force or enforce the complexity of the products of everything into an Inspire uniform. I remember also the element of granularity. Okay, I don't know if somebody would like to add something which I forgot, which you think really needs to be pointed out. No? Okay, well, then I would like to thank everybody here and have a good coffee break. Thank you very much.